Good morning, children.
Good morning, ma'am.
Good morning.
Good morning, ma'am.
Good morning, children. So before I start, my apologies for not being able to keep up the time. And the reason is I had a session in the morning from 8:30 and that was delayed, and I finished that by 10:30, and then I had to get back to make breakfast and have my breakfast and then start the session. So I thought I can start by 11:15, but anyway, again, it's delayed by 15 minutes, children. But anyways, we'll have class for 1 hour, 15 minutes. I assume that you don't have any other commitments during the same time. So now we start at 11:30, so till 12:45. We'll have the session till 12:45. Yeah, and regarding yesterday's class, I completely forgot. I normally that doesn't happen, but the same thing happened for Monday's class. I don't know why. I didn't register that at all. Monday's class I'd forgotten, and some text message reminded me about the class. So luckily I didn't miss that on Monday. But then Tuesday, some feeling that I had scheduled it only on Wednesday. I had some feeling I didn't check my message. I had some feeling that it was on. I had given the dates on Monday and then Wednesday. So I just assumed that, and I just didn't bother to, like see the messages which I posted. And then I got a call from Rakshita, which I did not notice. And then Florentina had called me. It was then I realized that I had scheduled a class for yesterday. But then at that time, I was in the middle of some other work, so I couldn't just start the meeting. So that's how I missed yesterday's class. So my sincere apologies for, whatever mistakes have been happened from my end. I'm very, very sorry about the same. Okay, so I think now we are ready to begin the session. So how many tangents can a circle have? How many tangents can a circle have? So a circle can have infinitely many tangents at different points. At a given point, it can have only one tangent. A circle can have only one tangent at a given point. But there is no mention of any point here. The question is, how many tangents can a circle have? A circle can have infinitely many tangents. If the question is specific, how many tangents can a circle have at a given point? At a given point, the circle can have only one tangent. But otherwise, a circle can have infinitely many tangents. At different points, it can have different tangents. I hope that's clear. So here the question is not specific. It's not how many tangents a circle can have at a point on it. So at a point on the at a given point on the circle, there can be only one tangent. But in general, a circle can have infinitely many tangents. All right, children? Am I clear?
Yes, ma'am.
Okay. A tangent to a circle. So this is exercise, the first exercise, I think 10.1. Okay, so yeah. A tangent to a circle intersects it in dash points. One point or many points?
1 point, ma'am.
Yeah, because it is a tangent. A tangent means one tangent to a circle intersects it in one or many points. Not many points, one point. A line intersecting a circle. A line intersecting a circle in 2 points is called a line intersecting a circle in 2 points is called a
Secant.
secant. Very good. Was that Sashank?
Yes, ma'am.
Yeah, secant. Very good. A circle can have dash parallel tangents at the most.
2.
Yeah, so now I'm sure you might have a doubt or a question in your mind. So you have to, sometimes in CBSE, it is the appropriate answer. Okay, whatever suits that situation. Okay, so a circle can have a dash parallel tangents at the most. So 2 parallel tangents at the most. Very good. The common point of a tangent to a circle is the common point of a tangent to a circle and the circle is called
Point of contact.
Point of contact. That is the point that is common to the tangent and the circle. The point, see, this is how we understood. A circle has infinitely many points on it. A tangent also has infinitely many points on it. There is only one point that is common to the circle and the tangent. And that point is called the point of contact. A circle has infinitely many points on it. A tangent also has infinitely many points on it. There is only one point that is common to the circle. I should say the circle and the line. That is why the line becomes a tangent to the circle. Okay, so that common point of a tangent to a circle and the circle is called the point of contact. Point of contact. You don't have to write all this now, children. Is that fine?
Yes.
Yes, ma'am.
Yes, ma'am.
Yes. A tangent PQ at a point P of a circle. So see here, circle, circle, point P of a circle, circle, point P. So any point P, a tangent PQ. So point P is on the circle. That means Q is the external point. See there, a tangent PQ. Now, tangent PQ meaning one point should be on the circle and the other point should be outside the circle. So since P is on the circle, Q is outside the circle. Q is outside the circle. A tangent PQ at a point P of a circle of radius 5 centimeters. So radius 5 centimeters. Meets a line through the center O at a point Q. So that OQ is equal to 12 centimeters. OQ is equal to 12 centimeters. Length PQ is, you need to find the length of the line segment PQ. You need to find the length of the line segment PQ. And since radius is perpendicular to the tangent to the point of contact, OPQ is a right triangle and you can find PQ using Pythagoras theorem. So PQ will be equal to the square root of hypotenuse is OQ. So 12 square, 144 minus 5 square, 25. So PQ is equal to the square root of the difference is 119. Yeah, 119 centimeter. P is a point on the circle. PQ is a tangent. So clearly Q is not a point on the circle or inside the circle. Since PQ is a tangent and it's given that P is a point on the circle, Q cannot lie inside the circle. Q cannot lie on the circle. It has to be outside the circle. So that's why we have this line segment PQ. And then we drew OP because the radius is given. So we drew OP 5 centimeters. And it's also given that OQ is 12. So you had to connect O and Q. OQ is 12. So you had to connect O and Q. So that brings this triangle OPQ, which is not given to be a right triangle, but we know that it's a right triangle by the theorem radius perpendicular to tangent. So this is 90 degrees. It's a right triangle. OQ is the hypotenuse. So you can find PQ using Pythagoras theorem. Is that fine, children?
Yes, ma'am.
Yes, ma'am.
Yeah. The notes will be uploaded in the library in your portal. I'll let you know when it's done because these are very simple stuff. So I don't want you to write this in the class now. I'll upload it in the portal and let you know. Theorems will come back. I'll collect all the theorems and do it together. So, okay, this is draw. Draw a circle. Okay, draw, not construct, children. There's a difference between draw and construct. Constructors, you'll have to do it using a pair of compass and a scale. You can use only a pencil fitted to a pair of compass, or a pair of compasses, and a scale. That is construction. Draw meaning you can just, it's just a representation. It's, you don't have to be accurate. Draw a circle. Okay, so I draw a circle. You will use a compass for a circle, or you can also use a bangle or anything circular. So draw a circle and two lines parallel to a given line. such that one is a tangent and the other is a secant to the circle. Okay, I'll read it again slowly. Draw a circle. So here we have a circle. We can draw the circle using anything that is circular. Okay, because it's draw a circle and two lines parallel to a given line. So you'll have to take one line. You'll have to take one line and you'll have to draw two other lines parallel to a given line such that one is a tangent and the other is a secant to this circle. Do we understand that? So you draw two lines, two parallel lines, two lines parallel to the given line. So you can take that line anywhere. That given line, you can take it anywhere because it's a line. There's nothing mentioned. You can take that line anywhere. You must draw two other lines parallel to the given line such that one line is a tangent and the other is a secant. So supposing we take this as the given line. Or you can also take this as the given line. So draw a line, just show, represent, sorry. So this is the tangent parallel to the given line. And this is the secant parallel to the given line. So basically you'll have to have three parallel lines, of which one is the given line, one is a tangent to the circle, and the other is a secant to the circle. All the three lines are parallel to one another. Just a representation. It's not construction. So for this one, this will be the tangent parallel, no? So the tangent will be here. This is a tangent, and that the given line itself is a secant, and this is also a secant parallel to the given line. Draw a circle. Take a line anywhere. It's not given specifically. So take a line, draw a circle and take a line. This is the given line. Draw two more lines. One should be a tangent, the other should be a secant. And all the three lines must be parallel to one another. So here is the line parallel to the given line, which is a tangent. And here is another line parallel to the given line, which is a secant. Is that fine, children?
Yes, ma'am.
Yes, ma'am.
Very good. I'll let you go. That's about the first exercise. Yeah. Exercise 10.2, example 1. Prove that in two concentric circles. So you can see the figure alongside. In two concentric circles, the chord of the larger circle. So name the chord of the larger circle. Name the chord of the larger circle.
AB, ma'am.
AB. AB is the chord of the larger circle. And what is AB to the smaller circle?
A tangent, ma'am.
Tangent. AB is a so AB is one line segment, but it has two different relations with the two circles. So AB is a chord for the outer circle and a tangent for the inner circle at P. For the outer circle or for the larger circle, AB is a chord. For the inner circle or the smaller circle, AB is a tangent at P. Prove that in two concentric circles, the chord of the larger circle, which touches the smaller circle, meaning tangent, is bisected at the point of contact. So you need to, what do we have to prove, children? I'll give you a minute's time. Read and tell me what is to be proved. I'll ask you, don't answer now. All of you, take a minute's time to read the question and understand. I'll ask you and then answer. What is to be proved? Is Sri Ranjan there? Yes, Sri Ranjan. What is to be proved?
Ma'am?
Yeah. To prove that it's bisected at the point of contact. So what should we prove? See, I'll tell you, I'll just tell you what I'm expecting. Okay, so maybe you don't understand what I'm expecting. Supposing we had the line segments like this. So you can say prove that. I'm just saying, for example, prove that OA is equal to OB. Or prove that, something like OP is equal to OB. So like that. To prove that, no problem, no problem. Yeah, we'll understand now. Tanishka, to prove that
AP is equal to BP, ma'am.
AP is equal to BP, correct. To prove that AP is equal to BP, because we need to prove that the chord of the larger circle, which touches the smaller circle, that is the tangent AB, is bisected at P. So we need to prove that AP is equal to BP. This is what we'll have to prove. So for that, we have two ways. One is you can use congruency. Join, you'll have to say join OA, join OB. Okay. So like that, we have two triangles, join OA and OB. Join OA and OB. So you have two triangles. So in triangle OPA and triangle OPB. Tell me the equalities we have. 90 degrees is not given, children. 90 degrees is not given. You have to write that. That's not given there.
OP is equal to OP.
Ma'am, radius is perpendicular to the tangent, so that angle OPB is equal to angle OPA.
Very good. So angle OPB, let me number it one. Okay, OPB, OPA. Angle OPA is equal to angle OPB is equal to 90 degrees. Reason, radius perpendicular to tangent. Very good. Okay, thank you, Sashank. Somebody else?
Ma'am, OA is equal to OB.
OA is equal to OB. Okay, OA is equal to OB. Reason?
Because they're both the radius of the circle, ma'am.
Correct. Radius of the circle and okay, radii.
Ma'am, OP is equal to OP common.
OP is equal to OP common side.
OP equal to OP.
Correct. What's the congruence rule then?
No rule, ma'am.
No rule.
SAS, ma'am.
SAS.
Ma'am,
Yeah,
but it is not possible, ma'am.
It's not possible. Okay, fine. I'll collect the answers from you. Yeah, okay. Sashank says it's not possible. Somebody said SAS.
RHS, ma'am.
Who's that? Rakshita. Very good. RHS. RHS congruence criterion. The two triangles are congruent. Right angle. OA, OB are the hypotenuses in the respective right triangles. OA is the hypotenuse, it's the radius as well as the hypotenuse of right triangle OPA. OB is the radius as well as the hypotenuse of the right triangle OPB. RH and side, some other side. So by RHS congruence criterion, the two triangles are congruent to each other. So triangle OPA is congruent to triangle OPB by RHS rule. So CPCT, we have PA is equal to PB or AP is equal to BP, correct?
Yes, ma'am.
Yes, ma'am.
Just practice this proof. You don't have to write the question, children. Just get a rough notebook. And just practice this proof. You can write it in your tuition classwork notebook neatly later with the question and the diagram and all that. Now I just want you to write out. Just practice this in your rough notebook. I'll give you 3-4 minutes time for that. Understand, read the proof once and then write it out. I'll just come back in 3 minutes. Practice, children.
Yes, ma'am.
Yeah. Okay. This proof involves, no, I think, okay, it's here. Yeah, no, we'll do this one. This one involves similarity. So I'll just keep it to the end because I need to give you some introduction about similar triangles. So we'll not spend time on that now. I need to give you some introduction to similar triangles and then explain this proof. So this one for now we'll postpone. Yeah, we'll do this one. So here two tangents, TP and TQ, are drawn to a circle with center O from an external point T. Prove that PTQ, this one, PTQ, angle 1, is equal to twice of angle OPQ, this one. You need to prove that angle 1. You need to prove that angle 1 is equal to twice of angle 2. Angle 1 is equal to twice of angle 2. Okay. Now, tell me, children, in triangle PTQ, Say something about this triangle PTQ, children. Anything regarding the sides or the angles in triangle PTQ.
PT is equal to PQ, ma'am. Because they're both tangent.
No. You said what?
PT is equal to PQ. QT, ma'am.
PT is equal to QT. Yeah, in triangle PTQ, PT, or we'll say TP is equal to TQ. Why? Why is TP equal to TQ?
Because they're both tangents.
Because they're the tangents from the same external point T to the same circle. Tangents from the same external point to two different circles are not equal in length. Need not be equal in length. See, if you have two circles, and from an external point, you have a tangent to both the circles. They are not equal. They need not be equal. So from the same external point T, we have TP tangent to one circle and TQ tangent to another circle. From the same external point T, we have TP tangent to one circle with center O and TQ tangent to the other circle with center O dash. Now these two tangents need not be equal. TP need not be equal to TQ. Maybe if it is given that TP is 5 centimeters and TQ is also 5 centimeters, it's possible. It's possible. That's why I said I didn't say they cannot be equal. I said they need not be equal. So maybe in a specific situation, TP is 5 centimeters, TQ is also 5 centimeters, so they can be equal. But they're not always equal. So tangents from the same external point to the same circle are equal in length. Okay. So here, as Madhumita said, TP is equal to TQ. So you know the reason. Tangents from the same external point to the circle are equal. That's the second theorem we learned in this chapter. After radius perpendicular to tangent, this is what we learned. After radius perpendicular to tangent, we learned that TP is equal to TQ. Tangents from the same external point T to the circle are equal in length. Okay. So now, if TP is equal to TQ, you can use the isosceles triangle property, right? You can use the isosceles triangle property, right? Can we say that angle 3 is equal to angle 4? Because in a triangle, when two sides are equal, the angles opposite to them are also equal, right?
Yes.
Yes, ma'am.
Yeah, because TP is equal to TQ, the angles opposite to them. So the angle opposite to TP is angle 4. The angle opposite to side TP is angle 4. And the angle opposite to side TQ is angle 3. So this is by isosceles triangle property. In a triangle, when two sides are equal, the angles opposite to them are also equal. Now use the angle sum property in the same triangle. In the same triangle, use the angle sum property. So what do we have? Angle 1 plus angle 3 plus angle 4 is equal to 180. Angle 1 plus angle 3 plus angle 3 is equal to 180. So what is twice of angle 3? 180 minus angle 1. Yes or no?
Yes, ma'am.
Now you'll be wondering like why are you having angle 3 on one side and taking 1 to the other side? I'll tell you that. So angle twice of angle 3 is equal to 180 minus angle 1, correct? Now,
Yes.
yeah, what is the other? Now the thing is, in the result we have angle 1 and angle 2. In the result we have angle 1 and angle 2. But here with us we have angle 3 and angle 1. You forget the constants 2 and 180. That will automatically, be removed. If it's not required in the final result, automatically that will be removed. Forget the constants. Okay. Now talking about the angles in the question, the result has angle 1 and angle 2. But here with us we have angle 1 and angle 3, which means we'll have to remove angle 3 and write that in terms of angle 2. Yes or no?
Yes, ma'am.
We'll have to, because we have angle 1. So angle 1 we need in the final result. So let that remain. Angle 3 you should take away angle 3 and write that in terms of angle 2 because the result has angle 2. So tell me, how will you write what is
angle
the
3 plus angle?
Yeah, what is the relationship between angle 2 and 3? How can you connect them in an equation? Yes, Ashank.
Angle 3 plus angle 2 is equal to 90 degrees.
Very good. Angle 3 plus angle 2 is equal to 90 degrees. That's the relationship between them. Angle 3 plus 2 is equal to 90 because radius OP, tangent TP. So 2 plus 3 is 90 degrees. So what is angle 3? What is angle 3? Using this, what is angle 3?
90 minus
90 minus angle
90 minus angle 2. So we, replace angle 3 with 90 degrees minus angle 2, correct? Is equal to 180 minus 1, is equal to 180 minus 1. Is equal to 180 minus 1. Now open the bracket. So 180 degrees minus twice of angle 2 is equal to 180 degrees minus angle 1. So 180 on either side gets cancelled. Minus sign on both the sides gets cancelled. So angle 2, twice of angle 2 is equal to angle 1. And this is what we had to prove, hence prove. So we'll do the whole thing again. So once I write it, go through the proof and practice it in your rough notebook. Don't write the question and don't take the diagram. Simply practice the proof. Yeah, so we first started with the triangle. In triangle TPQ. Yeah, please continue. In triangle TPQ, what?
TP is equal to TQ.
TP is equal to TQ. Therefore, by isosceles triangle property, what?
Angle 3 is
Angle
equal
3 is
to
equal to angle 4.
Angle 3 is equal to 4 or angle 4 is equal to angle 3, whatever. Okay. Then next, after this, what did we do? We use the angle sum property. Tell me.
Angle 1 plus angle 3 plus angle 4 gives 180.
Equal to 180, angle sum property. I'll just write ASP, angle sum property. So then angle 1 plus. Now, why did we take away 4 and introduce 3? We took away 4 and introduced 3 because 3 is closer to 2. See, in the final result, you want 1 and 2. You don't want 3 and 4. Here we have 3 and 4. In the final result, you want angle 1 and you want angle 2. But 2, we have 3 and 4. So slowly you should go towards 2. So first step, we'll take away 4 and introduce 3. And then we'll remove 3 and introduce 2 because 3 and 2 are related. So like that. So here what we do, we retain angle 3. We retain angle 3 because 3 and 2 are related. So we'll retain angle 3. 4 is replaced with 3 is equal to 180. So twice of angle 3 is equal to, you see, it's not that you should take it to the other side, children. See, all this is, you can have it like this itself. Angle 1 plus twice of angle 3 is equal to 180. You can have it like this itself, not that you should transpose. Now, this is one result. You can just stop here because we don't know how to proceed. Now, as Sashank said, angle 2 plus angle 3 is equal to 90 degrees because radius perpendicular to tangent. So from this, we have angle 3 is equal to 90 minus angle 2. You can say, you can just call this result 2. Then say using result 2 in result 1. What do you get? Angle 1 plus twice of angle 3. Angle 3 is 90 minus angle 2 is equal to 180. So angle 1 plus 180 minus twice angle 2 is equal to 180. So 180 on either side gets cancelled. So like this, angle 1 is equal to twice of angle 2, hence proved. Yeah, practice in your rough notebook, children. Done, children? Yeah, okay. Now this one I'm going to come from behind. Yeah. This is so this chapter has only 2 exercises in NCERT, exercise 10.1 and 10.2. 10.1 we finished. You saw the fill in the blanks and then I think 2 questions there. 10.2 we just finished the examples. There are 3 examples. I didn't do the third one. I told you I have to give you introduction to similar triangles for that. Now this is exercise 10.2, the last one. Prove that the opposite sides of a quadrilateral circumscribing a circle subtend supplementary angles at the center of the circle. Yeah. So prove that the opposite sides of a quadrilateral circumscribing a circle subtend supplementary angles at the center of the circle. Okay, so circle. There is a quadrilateral circumscribing this circle. Circumscribing meaning outside. A quadrilateral circumscribes this circle, so it's outside, like this. It's like this outside. So here you can see a quadrilateral circumscribing a circle. Okay, so quadrilateral circumscribing a circle. Opposite sides of the quadrilateral. Opposite side. These two, one pair of opposite sides. These two, another pair of opposite sides. So opposite sides of the quadrilateral, they subtend supplementary angles at the center. Again, I told you how to identify the angle subtended by a line segment. So if this is the line segment, and they give you a point O here, if you join the, so we have a line segment AB and we have a point O. If you have to identify the angle subtended by the line segment AB at O, you'll have to join the ends of the line segment to O. Join the ends of the line segment to O. This is the angle subtended by this line segment at the point O. Similarly, this is one side of the quadrilateral. This is the center of the circle. Join, see if this is AB, join A to O and B to O. This is the angle subtended by side AB at the center. Now, this is the side CD, opposite side. So join C to O and D to O. Remember that AC need not be the diagonal of the quadrilateral ABCD. See, AO can be like this and CO can be like this. AC need not be a straight line, meaning AC need not be the diagonal. AC need not be the diagonal of the quadrilateral ABCD. OA and OC are, like broken lines kind of. So it's not one straight line. So this can be OA like this and OC can be like this. Now, the other pair of opposite sides, BC and AD. So this is the angle subtended by BC at the center. This is the angle subtended by AD at the center. So what do we have to understand? Circle. There's a quadrilateral circumscribing the circle. There's a quadrilateral circumscribing the circle. Okay, like this. Ignore these extra lines. If I Try to erase it, the whole thing will go away. Ignore all this. So this is the quadrilateral circumscribing the circle, center of the circle. PQRS is the quadrilateral circumscribing the circle with center O. PQ and RS are the opposite sides, one pair of opposite sides. Join P to O and Q to O. This is the angle subtended by PQ at the center. Join S to O and R to O. This is the angle subtended by SR at the center. Similarly, this is the angle subtended by PS at the center. This is the angle subtended by QR at the center. Now we need to prove that the opposite sides, they subtend supplementary angles at the center. So you'll have to prove that angle 1 plus angle 2 is equal to 180. Opposite sides, no. So opposite sides, they subtend angle 1 and angle 2. You must prove that they are supplementary angles. That is 1 plus 2 is 180. Also 3 plus 4 is equal to 180. You need to prove that 1 plus 3 is, sorry, opposite angles. 1 plus 2 is 180 and 3 plus 4 is also 180. Situation is understood, children?
Yes, ma'am.
Yes.
Yeah, tell me, Rakshita, what is that we have to prove?
Ma'am, we have to prove that angle 1 plus angle 2 is equal to 180 degree and angle 3 plus angle 4 is equal to 180 degree.
Why should we not prove that 1 plus 2 is 90 degrees? Why only 180?
Ma'am, because they are telling supplementary angles.
Yeah, because we'll have to prove that they're subtend supplementary angles at the center, meaning 1 plus 2 is 180 we have to prove, not 90. If they say complementary angles, then 1 plus 2 is 90, 3 plus 4 is 90. All right. So which is the angle subtended by the side PS at the center? Class, side PS subtends which angle at the center?
Angle 3.
Angle 3. Which is the angle subtended by the side QR at the center?
Angle 4.
Angle 4.
Angle 4. Okay, children. So after this, after this you need to join. So now you can see that, okay, how many tangents does this circle with center O have any tangents?
Yes, ma'am.
How many?
4, ma'am.
That means the sides of the quadrilateral, they are tangential to the circle, correct?
Yes, ma'am.
Yes,
Yeah. So the sides, yeah, all the sides of the quadrilateral PQRS are tangential to the circle with center O. The sides of the quadrilateral PQRS are tangential to the circle. So let's mark off the points of contact. Let's mark off the points of contact as A. Okay, PQ, QR. So B, C, and D. A, B, C, and D are the points of contact. Now you have to join. Construction is join the points of contact to the center. Join the points of contact to the center. So join OA, OB, OC, and OD. All right. Join the points of contact to the center. Is that fine, children? Now you have to, yeah, very good. So now what you have to do is you will have to, okay. Now tell me the points like, tell me a point or points lying inside the circle. Tell me a point or points lying inside the circle.
O.
O is the, in this figure, O is the only point lying inside the circle. Tell me all the points that lie on the circle.
D, A, B, C.
Yeah, A, B, C, and D. That is the points of contact. A, B, C, and D. Name all the points that lie outside the circle.
PQRS.
PQRS. So see, like this, every point has some connection with the circle. That's what we learned in the first class. Every point in this plane, you can relate to every point in this plane with respect to the circle. So point O lies inside the circle. points A, B, C, and D lie on the circle. Points P, Q, R, S lie outside the circle. Now, which is the name the line segments that connect the center of the circle and the external point? Name the line segments.
OP, OQ, OR, OS.
Yeah. OP is the line segment joining the center and the external point P. OQ is a line segment joining the center of the circle and the external point Q. OR is the line segment joining the center of the circle and the external point R. OS is again a line segment joining the center of the circle and the external point S. Now, can you see? Sorry, just a minute. I dropped something down. Just a minute. Yeah. You can see now name the two triangles with OP as a common side. Name the two triangles with OP as a common side.
OSP and OQP.
One second. Yeah. Okay, so the common side, OP, OQ, OR, OS. Yeah. Yes.
A triangle OQP. OQP. QP.
No. Oh, okay. Okay. OQP
and OSP.
No, but that has two triangles in it. There should be only one triangle. That OPQ itself has two triangles in it. I want only the figure you say there should be only one triangle. There should not be any other triangle in it.
Triangle ODP and OAP.
Yeah, so triangle O
DP
and triangle
OAP.
OAP. So it's very easy. See here, you can just do it like this. See, OP is a common side, right? OP is a common side. So you can see here, OPA, you can see that you just need one more letter to complete the triangle. OP you already have. You just have one more, you just need one more letter to complete the triangle. OPA, OPD. On either sides of OP, you can see OPA, OPD. Correct? Yes, Sri Ranjan, tell me two triangles with OQ as a common side. Sri Ranjan, two triangles with OQ as a common side. Arjun.
Ma'am.
Yeah. Two triangles.
OBQ and OCQ.
Oh, no, start like this. OQ.
OQC and OQB.
OQC is a triangle. See the points just near OQ, no, on one side and other side of OQ. Okay, you tell the next one, Arjun. Okay, now tell me, somebody else tell me OQ.
A and OQB, ma'am.
OQA and OQB. OQA, OQB. Arjun, next one, OR. OR. Okay, fine. So I should make it more simpler for you. Now, all of you. So see here, children, it's just, you can just identify this quadrilateral. No, see with this OP as a diagonal. Can you see this one? Can you see this one? ODP, that is OPD, OPA. Then see this one. Now we said OPA, OPD, that is these two. Then we said OQA, OQB. Now tell me, Arjun, complete the remaining two sets of triangles.
Ma'am, ORC and ORB.
ORB and
ORC.
ORC. Then finally, OS.
OSD and OSC.
These two triangles. Then, oh, I'm sorry, I didn't listen to you. OSC and
OSD.
OSD. All of you understand? I'll put an exclamation for this. Now you have to prove that these triangles are congruent to each other. That is, you must prove that OPA. That is very simple. You just have to prove that OR, what is this? ORB. You will have to prove that these triangles are congruent to each other. Congruent to each other. Okay. So once you prove that the triangle is congruent, these are the results you will get. When you prove that this triangle is congruent to this result, I'm sorry, when you prove that this triangle is congruent to this triangle, you will be able to show that CPCT, this angle is equal to this angle. That is this angle, children, this angle is equal to this angle. Okay. In this figure, if I say, if I can show you in this figure, it is this, forget the names of the triangles, they're named in different ways here, but I'm seeing the position. This angle is equal to this angle. When you prove that these two triangles are congruent, you can get CPCTC, angle 1 is equal to angle 8. When you prove that this triangle is congruent to this triangle, CPCT, angle 2 is equal to angle 3. Then when you prove that this triangle is congruent to this triangle, you will get CPCTC, angle 4 is equal to angle 5. And when you prove that this triangle is congruent to this triangle, angle 6 is equal to angle 7, CPCT. Okay. So this is what you should do. You must prove that these two triangles are congruent to each other. These two triangles are congruent to each other. That is easy. Then this triangle is congruent to this triangle. This triangle is congruent to this triangle. So once you prove that, you will get these results. What results? You will get angle 1 is equal to angle 8 CPCT. Angle 2 is equal to angle 3 CPCT. Angle 4 is equal to angle 5 CPCT. And angle 6 is equal to angle 7 CPCT. Because these are the pairs of triangles. These are this triangle and this triangle, this triangle and this triangle, this triangle and this triangle, this triangle and this triangle. So you cannot get 1 is equal to 2, children. Simply don't write any two angles. Don't write 1 is equal to 2, 3 is equal to 4 in any way. Angle 1 and angle 8 are in those two triangles. Now, after this, you must use the property that the sum of all the angles around a point is equal to 360 degrees. You must use the property that sum of all the angles around a point is equal to 360 degrees. So angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5 plus angle 6 plus angle 7 plus angle 8 is equal to 360 degrees, because sum of all the angles around a point is 360. Now, what is it you have to prove? That's very important. What is it you have to prove? We have to prove that angle AOB plus angle COD is equal to 180. In other words, AOB is made up of angle 1 and 2. Angle 1 plus angle 2. AOB is nothing but angle 1 plus angle 2. Plus COD is nothing but, what is COD, children? What is
Angle
COD?
5 plus angle 6.
Yeah, angle 5 plus angle 6 is equal to 180. This is what you'll have to prove. And then what's the other one? What's the second one? No, why only 3 to 4 people are active today? Danya told me she's traveling, so she will not be able to participate. Okay. What about the others? Dileepan, or do you all need an invitation to talk? Dileepan, Sri Ranjan, Arjun. Please participate voluntarily. Arjun is always quiet in online meetings. Florentina also, always quiet. You answer only fast. See, always active participants are Danya. Today she's traveling. Prajit, very active. Sashank, very active. Madhumita also. Rakshita. That's all. Tanishka sometimes. Krishmi, you have a issue with your mic and you have not still fixed it. So there's how can you attend an online class without being able to participate in the meeting? So you need to fix that. Tanishka rarely. Krishmi is not able to talk because she does not have the mic issue still fixed. Please fix it, Krishmi. Ranjan does not participate. Dileepan does not. Rakshita, yes, she does. Raghavi, no. Madhumita, yes, she does participate. Sashank also, yes. Prajit, yes. Florentina, no. Danya, yes. Arjun, no. All these no's. Please participate without, I don't have to ask you. I want all of you to answer. You can just, when I ask the class to answer, please be the first one to turn on your mic and answer. Arjun, what is the other thing I have to prove? Fast. Dileepan.
AOD is here. AOD plus BOC is equals to 180.
AOC.
AOD.
AOD plus?
AOD plus BOC is equals to 180.
Okay, now break down angle BOC. BOC is made up of?
Angle 3 plus angle 4.
And AOD?
Angle 8 plus angle 7.
Very good. Okay, so this is what we have to prove. All right. So now these results we got from congruency, CPCT, we got these results. Now this is in general, sum of all the angles around a point is 360. Sum of all angles. Now to get the first result, you need angles 1, 2, 5, 6. So we need 1, 2, 5 and 6 to get the first result. So you don't want these angles. You don't want these angles. Replace. So write angle 1 plus angle 2. Replace angle 3 with what? Angle 3 is equal to class?
Angle 2, ma'am.
Angle 2. Angle 4 is equal to?
Angle 5.
5. Should I write 5 and 6 as they are, or should we replace?
Ma'am, we have to write it as they are.
Yeah, no, 1 minute. I don't know if all of us are following. See here. To get this first result, we need angles 1, 2, 5, and 6. So we are making use of this result, right? So we want angle 1, we want angle 2, we want angle 5, we want angle 6. We don't want these angles. We want to replace only these angles. So we'll write angle 1 plus 2 as it is. 3 is replaced with 2 because they're equal. 4 is replaced with 5 because they're equal. Then continue. Continue. What should I write?
Angle 5 plus angle 6 plus angle 6 plus angle 1
is equal to
360 degrees, ma'am.
Yeah. So now what is angle 1 plus angle 1? Twice of angle 1. What is angle 2 plus angle 2? Twice of angle 2. Angle 5 plus y, twice of angle 5, twice of angle 6 is equal to 360 degrees. So when you take out 2 common, angle 1 plus angle 2 plus angle 5 plus angle 6 is equal to 360. So you'll get angle 1 plus 2 is what? 1 plus 2 is angle AOB. Angle AOB. Plus angle 5 plus 6 is COD is equal to 360 by 2. Into 2 comes for division to the other side. Division to the other side. So 360 by 2, 180 degrees. So we proved the first result. Now to get the second result, you can do it in the same way. You can again start from the beginning. You can do it in the same way. You need angles 3, 4, 7, and 8. So you don't want the remaining angles. So replace in the same way you can get it. Or what you can do is this understood, children, till here?
Yes, ma'am.
Yes, ma'am.
Okay. So now you can just write it in short, this one. Take the next slide. See here. AOB, BOC, COD, AOD. AOB, BOC, COD plus AOD is equal to 360. Same thing, sum of all the angles around a point. See here. Angle AOD plus angle BOC plus angle COD plus angle AOD is 180. Sum of all the angles around a point. Sum of all the angles around a point is 360 degrees. That's what I've written here. AOB, BOC, COD, AOD. Sum of all the angles around a point is 360. But we know that AOB plus COD is 180. AOB plus COD. AOB plus COD. This one together is 180. Plus BOC plus AOD. Because these two together is 180. So I remove that and write 180. Plus BOC plus AOD is equal to 360. So BOC plus AOD is equal to 360 minus 180, which is 180. So we proved that BOC, this one, plus AOD is 180. Is that fine, children?
Yes, ma'am.
Yes, ma'am.
Okay. Okay. Now let's not take up any other proof. Find x, children. Find x. If this is 25 degrees, find x. Okay, this is a general question, not related to circles. Give a special name. Give a special name.
65 degrees.
Oh, very good. Okay. Okay, 1 minute. Give a special name to the quadrilateral ABCO. This is a general question. Okay. Yeah. Sashank, 65. Huh?
Yes, ma'am.
Can you explain?
Yes, ma'am.
Yeah.
Ma'am, radius of both the triangles are equal, ma'am.
Okay.
So that then angle OAB is equal to angle OCB.
Okay.
And then due to RHS, triangle AOB is congruent to triangle COB.
Okay.
Therefore, angle CBO is equal to 25 degree.
Okay.
And angle OCB is equal to 90 degree.
Very good. Okay.
Then by ASP we can find.
Very
Yes.
good. Very good. Very good. Perfect. Yes. So if this is for 2 marks, then you have to show that these two triangles are congruent. If it is for 2 marks, then you'll have to show that these two triangles are congruent. So CPCT, this angle is equal to this angle. So this is also 25 degrees. And then this is 90 because radius perpendicular to tangent. And then angle sum property. Somebody's mic is enabled. Please disable your mic. And then by using angle sum property, x plus 90 plus 25 is equal to 180. So x will be equal to 65 degrees. If it is for 2 marks, then we have to show that these two triangles are congruent. Then CPCT, this also is 25 degrees. This is 90 degrees because radius perpendicular to tangent. So in this triangle, we know one angle is 90, one angle is 25. The third angle is x. So you can find this using angle sum property. So x is equal to 65 degrees. If it's an MCQ, if it's an MCQ, we don't have to do all this. We learned yesterday that equal tangents are equally inclined. Okay, we learned that equal tangents are equally inclined. So always this angle will be equal to this angle, always. Equal tangents are equally inclined. So this angle will be equal to this angle. So this is also 25. Then quickly you must write 90 here. So if this is 25, this is 25 because equal inclination. And then this is 90. So 90 plus 25 is, or you can also do like this is 90. So the sum of the remaining two will be 90. In a triangle, if one angle is 90, the sum of the remaining two angles will be 90. So x plus 25 is 90 degrees. So x is equal to 90 minus 25, which is 65 degrees. Very good. Sashank, yeah, now class, give me a special name to the quadrilateral ABCO.
Ma'am, it's a rhombus.
Rhombus. Okay, just a minute.
Kite.
Just a minute. Kite, just a minute. Yes, Rakshita was right. It's a kite. It's not a rhombus because all the sides are not equal. In a rhombus, all sides are equal. It's a kite because adjacent sides. Two pairs of adjacent sides are equal. OA is equal to OC, radius. And AB is equal to, BC is equal to BA. Tangents from the same external point of the circle are equal. So since OA is equal to OC, radius, and BA is equal to BC, tangents from external point of the circle are equal, we have these two sides equal and these two sides equal, but all the sides are not equal. So the figure is a kite. It's a kite. OABC is a kite. Always a figure like this. Always a figure like this. That is from an external point B, you have BA, BC tangents, and then when you join the radius and all that, this figure is always a kite. Well recalled, Rakshita. So a kite is a quadrilateral in which two pairs of adjacent sides are equal. All of us understand? Class, use the emoji, raise your hand. See, there's already one person not in the meeting. Madhumita, Arjun, Dileepan, Prajit, Tanishka, Danya, Rakshita, Florentina, Sri Ranjan, Sashank, and Sri Krishmi. Can you guess who left the meeting? Raghavi. Raghavi was there, but she's not there now. And Ritika has not joined the meeting today. What do you call a quadrilateral in which no pair of opposite sides are parallel? What do you call a quadrilateral in which no pair of opposite sides is parallel?
Trapezium.
Okay, or you can say, give me an example of a quadrilateral where no pair of opposite sides is parallel. A special name.
Trapezium.
Oh, in a trapezium, one pair of opposite sides is parallel, no?
Yes, ma'am.
In a trapezium, one pair of opposite sides is parallel.
And rhombus.
Rhombus, both the pairs of opposite sides are parallel. The
Ma'am,
rhombus,
kite.
both the kite, yeah. A kite is a quadrilateral in which no pair of opposite sides is parallel. In a kite, this one is, these two sides are not parallel. If you produce them, they'll meet somewhere. They will meet. Opposite sides are not parallel here. In a trapezium, opposite sides are not parallel. They'll meet. A kite is also a quadrilateral in which no pair of opposite sides is parallel. A trapezium is a quadrilateral in which, a trapezium is a quadrilateral in which one pair of opposite sides is parallel. A parallelogram is a quadrilateral in which both the pairs of opposite sides are parallel. So under parallelogram, we have a rhombus, rectangle, and square. All these are parallelograms. All these are parallelograms. Rhombus, rectangle, square, all are parallelograms. Both the pairs of opposite sides are parallel. So no pair of opposite sides parallel, kite. One pair of opposite sides parallel, trapezium. Both the pairs of opposite sides parallel, parallelogram. Different types of parallelograms, rhombus, rectangle, square. Is that fine, children? Any questions so far?
No, ma'am.
No, ma'am.
All right, children. So that's it for today's session. Thank you so much. You may leave the call. So tomorrow is the regular class in the evening. Correct? We don't have a class in the morning, right? Tomorrow?
No, ma'am.
Yeah. So we'll meet tomorrow evening, regular class. All right, children. Thank you so much. You may leave the call.
Thank you, ma'am.
Thank you, ma'am.
Thank you.
Thank you, children.